So let us consider this question to use calculus to minimize the quantity. So we have a solid that is formed by adjoining two hemispherical solids to a right circular cylinder, and the volume is going to be, or volume of this resulting solid is, just a second, let me just adjoin them properly. Okay, so anyways, the x's then didn't coincide, hope you don't mind it. Okay, and then so the volume of this solid is given, or it rather has to be how much, or how many? 12 cubic inches. Now we have to find the radius of the cylinder in, so that the surface area of this new body is minimum, or is the minimum. So let's attempt the question. So we are given that the volume of this whole body is 12 cubic inches. So let's look at the hemisphere here and here, and we know that the volume of a sphere of radius x is 4/3 pi x cube, and then the volume of a cylinder is pi times the radius square times h, and that equals what? 12 cubic inches, right? And now what we have to do is that we have to minimize the surface area. So surface area would be what? The surface of the sphere, the two hemispheres combined, and that of the wall of the cylinder. Okay, so surface of a sphere of radius x is given by this quantity, 4 pi x square. And if you do this, and we just have to look at the wall of the cylinder. So if we look at the wall of the cylinder, let's just cut and expand it. So you will get a rectangle with height h, or altitude h, and this side will become what? Just the circumference of this circle here, right, which is 2 pi x. So what is that surface area then? 2 pi x h. Okay, so what we will do is, we are given this constraint, so we will go ahead and solve this for h and substitute that in here. So before we go ahead, let's get rid of the fractions. There's just one way of doing it. I mean, many of you may just not have to do it. Okay, so this is 4 pi x cubed. Just a second. Let me see. Let me just rewrite it as I'm just very new to this Microsoft whiteboard. Okay, so just forgive me for learning it on the job. Okay, so I'm multiplying it by 3. So we have 4 pi x cube plus 3 pi x square h equals 12 times 3 is 36. Now we will just move this to the other side, because our objective is to solve for h. So when we move this quantity to the other side, we get 3x square h equals how much? Okay, equals, let me just make my equal little better looking. Okay, so that equals 36 minus 4 pi x square, right? Okay, so, or no, sorry, the 4 pi x cube, that's what we shifted there. Okay, so what we get here, let me write it again, 3x square h equals 36 minus 4 pi x cube. So that gives us h equals what? 36 minus 4 pi x cube, right? Okay, one moment, let me write that cube again. Okay, so here x cube and divided by how much? 3x square, right? That's what our h will be. So now if we substitute this value of h in here, what do we get? 4 pi x square, then we have 2 pi x, okay, and h is going to be 36 minus 4 pi x cubed divided by 3, and I think I have left something out. Yes, I did. It should have been 3 pi x square. I forgot that pi here, so let's write the pi at the end. So here we have a pi and then x square. So these pi's cancel and this x will cancel this 2 here, right? Okay, so what happens is the quantity that we have to minimize is what? 2/3, okay, x, and then here I have 36 minus 4 pi x cubed, right? Okay, so now it has become a function of only one variable. So let's write the function and then we will go ahead and find its minimum, or find the value of x that minimizes this. Let's just go ahead and distribute this 2/3 x. So when we do that, 2/3 x plus 36 would be what? 3 times 12 is 36, so that will give us 24 over x, and then minus what we will have, 2 times 4 is 8 pi over 3. Now this x will change that x cubed to who? X square. So now we have to minimize this quantity. Let's just go ahead and do that. Now in order to do that, let's just go ahead and minimize this function. Let's go ahead and look at the derivative to find the critical points, okay, or critical numbers here. So derivative of x square is 2x, so we get 8 pi x, okay. 24 over x, that will be negative 24 over x square, and then we have x square here, that will be 2x, so the whole thing would be 16x over 16 pi x actually over 3, okay. Now what we will do is, in order to get the critical numbers, we will set this quantity equal to 0, and of course we know that our x has to be greater than 0 right from here, so we get 16 pi x over 3, all that equals 0, and we got x greater than 0. In order to have a positive volume, we will have to have that. Now to solve this for x, let's multiply by 3x square, which we are allowed to because x is not 0. So when we multiply by 3x square, okay, what shall we get is that we shall get 3x, so we will get 3 times 8 is 24 pi x cube minus 24 times 3 is 72, then minus 16 pi x, and then pi x times x square would be x cube again, so 16. Actually, I forgot writing my x, so 16 pi x cubed, okay, equals 0. Now, so which gives us how much? 8 pi x cube, okay, actually pi x cube. I am new with this Microsoft whiteboard, so learning on the job. So 8 pi x cube minus 72 equals 0. So what happens then is x cube is going to be 72 over 8 pi, or x cube is 9 over pi, okay, or in other words, x is 9 over pi to the power, one moment, 9 over pi, I have to write pi properly, pi to the power how much? 1/3, okay. Now, if we want to see that whether we are going to have a minimum or maximum, we can use the second derivative test here. That is, let's just go ahead and take the second derivative of the function, okay. Now, when we take the second derivative, what we will get is this. F double prime x is going to be 8 pi, then we have a plus 20, that would be 48 over x cubed, right? Because when you differentiate x to the -3, that will be x to the -2, that will be -3 times x to the -3, which will simplify to this, minus 16 pi over 3, and that's going to be how much? That's 16 pi over 3, so that's going to be 48 over x cube, and then 8 pi minus 16 pi over 3, 24 minus 16 is 8, so we get, I will do it if I can just write, okay, plus 8 pi over 3. Now, so for this value of x, what do we see? That f prime of this quantity, 9 pi over to the power 1/3, if we substitute that in here, will be positive. So when the second derivative is positive, means what? That corresponding critical number is going to give us a minimum. So the minimum is going to happen or occur at the radius equal to 9 over pi to the power 1/3. Okay, and I apologize, me doing this video while learning this whiteboard, okay, and appreciate your patience. All right.